Welcome to Deep Dive Learning by HaleForm.
Episode 3 is here.
Yes, Introduction to S3D Piping Part 1. Today, we're focusing on working with pipelines in Smart 3D. We know you, our listeners, like getting up to speed quickly, getting a real solid understanding.
Absolutely.
So today, we're diving straight into Smart 3D. It's a really powerful piece of software, isn't it?
Oh, definitely. And we're looking specifically at how it handles piping design.
Right, how it organizes and manages all those pipelines within the system itself.
That's the plan. And for this deep dive, we're drawing on, and also leaning on the expertise of HaleForm Technology Solutions. They really know their stuff when it comes to Smart 3D piping.
They certainly do. I mean, HaleForm Technology Solutions, they have this really strong team. They're proficient in the modeling, sure, but also administration.
Yeah, the back-end stuff, too.
And customization, things like catalog specifications, hangers, supports, all that detail.
It covers a lot of ground across different disciplines within Smart 3D.
So the mission today is really to unpack the fundamentals, working with pipelines in Smart 3D.
Getting that core understanding.
Exactly. How they're structured, how they're managed. We'll hit the key elements: piping systems, pipelines, pipe runs.
Features, parts.
Features, yes. And even how collaboration works in this environment.
And you've told us that you want to know the why, not just the what.
That's right. Efficiency, but also understanding the logic behind it.
So we'll definitely highlight those organizational principles within Smart 3D piping. So let's dive in. Where do we actually begin with piping in S3D?
Okay, starting point. According to the documentation, it's the piping task. That's your main zone.
Right, in the software itself.
Yeah, it's designed for that point-by-point modeling, creating the actual 3D model. You find it under tasks, then just click piping.
And you're not just dropping pipes anywhere, are you? There's guidance.
No, definitely not random. It's guided by something called a piping specification.
The spec. That's crucial. Think of it like a rule book or a pre-approved list for the pipeline's job.
So it tells you what parts you're allowed to use.
Pretty much. The spec pre-selects the parts based on the pipeline service, what it's carrying, the conditions.
And that considers things like cost, safety.
Exactly. Applicability, cost, procurement, safety, all those critical factors. It really streamlines the design. You're working with stuff that's already vetted.
Makes sense. Avoids costly mistakes down the line, I imagine.
Big time. It reduces the risk of picking something incompatible. And there are even rules within the spec.
Rules?
Yeah, rules that help select specific parts for certain design situations. It's like having built-in engineering logic.
Okay.
And if you really want the deep details on those specs, the piping reference data help or catalog help is where you'd look. Piping material classes define requirements for specific services.
Got it. So specs are key. Now, before we even place a part, the docs say understanding relationships is vital. What are these core concepts?
Yes, absolutely fundamental. You need to grasp how piping systems, pipelines, pipe runs, pipe features, pipe parts, ports, and connections all fit together.
It's like a hierarchy?
It is. It dictates the whole organization of your piping model.
Okay, let's break it down. First up, piping systems. What's their role?
Piping systems are like, high-level folders. They organize your pipelines.
How so? Based on what?
You can group them based on different criteria, maybe by area, like plant north, or by content, like steam system, or even by designer, whatever makes sense for the project.
So logical groupings.
Logical groupings, exactly. And you create these in the systems and specifications task. Think of them as the main organizers.
Right, the top level.
Yeah.
Then under that, we have pipelines. How are they different?
Pipelines are also organizational, but they group the pipe runs within the model. You also create these in the systems and specifications task.
So we have?
But here's a key thing. A pipeline doesn't have to live inside a piping system.
Oh, interesting. So they can be independent.
Yeah, you have that flexibility. When you create a pipeline, though, you do need to define its fluid requirement and type. What's it carrying?
Okay, so a system might hold several pipelines,
Yeah.
each doing something specific in that area. Makes sense. Next layer down, pipe runs.
Pipe runs are really fundamental. They're a connected series of, pipe features.
Features. We'll get to that.
We will. But pipe runs usually share the same nominal piping diameter, or NPD.
Pipe size, basically.
Right. Same size, same flow direction, and typically the same piping specification we talked about.
So the actual pathway for the fluid.
That's a good way to put it. A single pipeline is made up of one or often many pipe runs.
And these runs are built from pipe features. Tell me about those.
Okay, pipe features. Think of these as the logical pieces you place during routing. They define the high-level design intent.
Like I need a turn here or a branch there.
Exactly. The basic ones are straight features, turns like elbows, branches like T's, end features like caps, run changes where the size might change, splits, and also components that sit along the leg, like a valve.
And the software uses these features to pick the actual parts.
Yes, driven by the pipe spec assigned to that run. The software intelligently selects the physical parts. And remember, these specs can be customized in the reference data.
So it automates a lot of the component selection.
Yeah.
Which brings us to pipe parts.
Pipe parts are the actual physical things. The elbows, the pipes, the flanges, the valves you see in the 3D model.
The tangible components.
Right. And usually the software selects them automatically based on the feature and the spec. Like you place a valve feature, it adds the valve body, flanges, gaskets.
All necessary bits.
All the bits. But importantly, you can override this.
Manual control.
Sometimes needed, yeah. If the auto-selected part isn't quite right, you can manually pick a specific one. But even if you override, that part still belongs to only one pipe run.
Good to know. So automation plus flexibility. What about pipe ports and connections?
Simple enough. Pipe ports are just the connection points on the parts. The ends of a pipe, the nozzle on a vessel, the flange face on a valve.
Where things join up.
Exactly. And connections define how those ports link together. They create the actual joints, the continuity.
Making it a complete system. Okay, 2 more terms here. Pipe leg and boundary.
A pipe leg is basically a set of continuously connected features going in the same general direction, like a straight segment, maybe with a few fittings, but still heading one way.
Like a section of the run?
Kind of, yeah. You can select and modify things on the same leg. A boundary, though, is a specific point, a port on a terminal object marking a transition.
Like where something changes.
Right. Where the line spec changes or the size changes or you hit a branch point or the run splits. They define the limits or changes within the system.
Okay, that clarifies the building blocks really well. Now, shifting gears slightly, collaboration. How do multiple people work on this together? Permissions groups and routing.
Oh yeah, crucial. Smart 3D is designed for teams, different users, maybe with different privileges.
Especially in global workshare.
Right, exactly, especially then. They can all work on routing pipelines. When different runs need to connect, the software does something clever. It creates an intermediate end feature, an IEF.
IEF. What's that do?
Think of it like a virtual handshake point. It establishes a logical link between runs that might be owned or worked on by different people or different permission groups.
So my run connects to your run, but we don't directly edit each other's core features at that joint.
Precisely. The legs of the runs terminate at the IEF. They aren't shared across the runs themselves. It manages the connection point. And key to this is understanding how permissions are assigned.
Right. Who owns what?
When you create something directly, it usually gets your active permission group. But when the software creates something automatically, like an IEF or a connection,
it follows different rules.
It follows specific rules, yeah. And you need to be aware of those.
Okay, like what are some of those rules for auto-created stuff?
Well, parts that get generated as part of a feature inherit the feature's permission group. And features, like caps, use the run's permission group.
Makes sense.
Connections adopt the permission group of the parts they connect. Now, if the parts have different groups, the system tries to use the group that the user doing the connecting has right access to. It prioritizes that.
Okay, tries to make it work.
And piping connection objects, welds, gaskets generated by the connection, they inherit the permission of the connection itself.
It sounds like a fairly robust system for managing access. The docs also mention how this fits into the system hierarchy.
Yeah, that's important too. If you want to modify a system, say add a pipeline to it, you need right access to that parent system.
But not necessarily the system above that, the grandparent.
Correct. You generally need right access to the direct parent, but not necessarily further up the chain. Same for adding a run to a pipeline. You need access to the pipeline, but maybe not the overall piping system it sits in.
Good clarification.
Yeah.
And in global workshare, all this permission management happens centrally.
Yes, absolutely. All permission group management has to be done at the host site. Keeps things consistent and avoids conflicts across different locations working on the project.
Right. Okay, let's switch back to the practical side working in the software, creating these systems and pipelines.
Right. You can create a piping system either in the Systems and Specifications task where you're doing overall setup. Or you can do it right within the piping task itself, usually via a right-click in the Workspace Explorer. Either way, you define its properties afterwards.
It's similar for creating a pipeline system.
Same idea. Systems and specifications task using the ribbon command, where you define description, fluid requirement, type.
Or in the piping task.
Or via the Workspace Explorer in the piping task, entering similar info. And again, properties can always be edited later.
So flexibility on where you create them. Editing properties is straightforward.
Yeah, pretty standard. Select the pipeline in the graphic view or the Workspace Explorer, then edit properties. Adjust what you need.
What if you need to? Detach a pipeline. Break its
Yeah.
connections. There's a disconnect command.
Yes. Under Tools, Utilities, Disconnect command, you select the pipeline, run the command.
And it just removes the links.
It removes the logical relationships, yes, but also actually deletes the physical mating parts or transition pieces at the connection points.
Oh, so it physically breaks it.
It does. It's a significant action, so the software logs the details of what was disconnected.
Is there an undo? Please say there's an undo.
Yes, thankfully. There's an undo disconnect command. Very useful if you click the wrong thing.
Phew. Okay. And if you need to get rid of a pipeline entirely, deleting it.
Simple selection again. Select the pipeline, hit the delete key, or use the delete command. The documentation notes some specifics about how boundary connections are handled during deletion, which might matter in complex cases.
Okay. So from setting up the structure, creating the elements, managing connections, collaborating, modifying, Smart 3D seems to have a pretty comprehensive workflow.
It really does. And having that clear structure systems, pipelines, runs, features, is just essential for keeping complex piping designs organized and manageable.
Absolutely. And thinking about managing complexity, it's worth reminding everyone again about HaleForm Technology Solutions. Their expertise isn't just in the modeling itself.
No, it goes much deeper. They handle Smart 3D administration, really crucial stuff, customizing catalogs and specifications to match project needs.
Which we saw is fundamental.
And even programming for advanced customizations if you need really specific functionality.
So for any kind of Smart 3D requirement, they're a great resource. You can reach HaleForm at business.development@haleform.com.
Definitely keep them in mind. So wrapping this part up, what's the big takeaway for our listeners?
Well, I think we've really dug into how pipelines are structured and managed in Smart 3D, from the high-level systems down to the individual parts and connections.
You should have a much clearer idea now of those building blocks and how that underlying framework supports the design process.
Yeah, how even simple actions rely on that structured organization.
And here's something to maybe chew on. Think about that structured approach. Systems, pipelines as flows, features as specific elements. Could that kind of thinking, that structured way of breaking things down, be useful elsewhere? For organizing complex information in other parts of your work, or even just managing information overload generally?
That's a really interesting thought, applying that S3D logic outside of S3D. This deep dive, though, it's really just part one, isn't it?
Oh, yeah. We've just scratched the surface of working with pipelines. There's routing techniques, inserting components, managing specs in detail, lots more.
We hope this has whetted your appetite, sparked some curiosity, and given you a solid head start on understanding this crucial aspect of Smart 3D.
And if you do have more questions or want to explore specific bits further, the Smart 3D documentation is always there.
Or reach out to the experts.
Exactly. Like the team at HaleForm Technology Solutions. Again, that's business.development@haleform.com. They're ready to help with S3D piping and all related needs.
Fantastic. Well, thanks for joining us for this deep dive.
Until next time.
Keep exploring.